Is this too dark for y'all? Okay. So before we talk a little bit about the solution for this exercise, I just want to do a real quick overview of what we're going to be talking about today. Today's going to be a lot of reiteration over what we've already talked about on Monday, which would be the REST endpoints, which would be get, post, put, and delete. We're also going to talk a little bit about what an ORM is. It's called an object relational mapper, but we'll get into that in a little bit. I know last time we did the watch list application. That was the very last exercise we did in last class. This exercise should match that pretty closely. And so let's begin with the server.js. Well, actually, no, let's walk through the app and see what we're supposed to be getting out of this. Our app is a quotes app. What it takes is a quote, an author, and you have the ability to, one, get all these different quotes. We have the ability to create new quotes. We have the ability to update a quote and then also to delete a quote. These match hand in hand with the REST API endpoints that we saw last time. And let me find that little thing I wrote out. Where is this? There we go. So what we're doing is CRUD operations in a database. A CRUD would be a create, a read, an update, and a delete action on my database. These correlate directly to a post request for a create, which is an insert to the database, a get request, which is reading information from a database, and we're going to use a select query for that, we're going to have a put request, which is a update to the database using the update query statement, and then we have a delete request, which correlates to a delete action in the database, which also happens to be a delete statement in the MySQL database. So when we delete one of these quotes, it's going to refresh the page and we can see that quote is now gone. We can add a new quote. I don't know, we'll call him John, ABC, add quote. And a brand new quote is added to the database with an auto-generated ID. We can update this quote, DEF. But you'll notice that it moved us to a brand new page. So it didn't just refresh the page, it brought us to a new endpoint, which we can assume has its own template. We can update this quote, which brings us right back to our original page, and we can see that our quote has been updated over here. There's a few things we can assume just by the actions that we've seen. That is, one, there's two separate pages, so two separate templates. Two, the update action is the only one on the second page, while the delete, get, and post requests all happen on the same page. So, and every time they happen, the page is refreshed, and the new get request pulls in all the information it needs from the database, so it's always updated. When we take a look at the solution, we'll start with the very first step, which is, one, defining that this is an Express app. We're going to define our port. We're going to get into static in just a little bit, so let's ignore that for now. We're going to create a connection to our MySQL database, and the database that we're going to be interacting with will be the quotes DB. Once we initiate a connection, we now have the ability to run queries on that database. So, first things first, we need this page to get all the quotes from the database. This will be app.get on the home page, URL / and it will call a select star from all quotes in the database. It's just going to give us all the quotes. Nothing new over here. We're going to render the index template. Let's render that template and let's see what's inside. And all it's going to be is showing us that it's a quotes app with a header, manage the quotes within this app, and then there's going to be some handlebar specific syntax that will allow us to iterate through the quotes and display them on the screen. And there's just a little bit of CSS to make them look nicer with this background, orange background over here. Each individual quote will come with two buttons. One is a delete button that we see over here, and another one is just a URL link, an anchor link to update this quote. And you'll notice that one, the database button, the delete button has a data ID. I guess you'd call it a data ID key, and then the anchor is a / with the ID of the quote at the time. This ID correlates directly with what's in the database, which we're going to take a look at right now. So if I look at the quotes DB and look at the content, it'll be these individual IDs that you see over here that is being saved to the front end. Our rationale for that is that the only two actions over here that require an ID is update and delete. We need to know what element in the database we're updating, and we need to know what element in the database we're deleting. Getting all that data and creating new data does not require an ID. Why? What was that? Yeah, the question is, why do we not require an ID when we're getting information from the database and creating a new quote? Correct. Yeah, one, when we create a brand new quote, is auto-generated for us, and that is defined inside of the schema. We don't care about the ID when we're creating new quotes. All we care about is that there's an author and there's a quote. Secondly, when we're just saying, give me all of the quotes within the database, there is no specific where clause saying, give me one specific quote. We're getting all of them. So we don't necessarily care about the IDs at that point. For our exercise, the only time we care about an ID is when we're deleting a specific quote and then when we're updating a specific quote. And there needs to be a reference on that front end that you pass back to your back end, which actually does the updating, which actually does the deleting. If you don't pass back an ID, it's not going to do anything. Is that clear? Cool. Definitely raise your hands if I'm going too fast, so we really make sure we hammer this home. So then we're going to take a look at our post endpoint, which will be API quotes. Our post is going to do our create request. Where did it go? Over here. It's going to do our create request, where we insert into the quotes table an author and a quote, which you will find in the body of the request. When we see a statement like this, we know that on the front end, there has to be some type of form that's submitting this information to the back end, or how is it getting there? It's either going to be a AJAX call, or it's just going to be a typical a submit action. So let's take a look at this URL on the front end. I would assume, let's take a look in index. I'm unable to find, so then when we go to quotes, not looking in the right place. All right, let's go to main handlebar. Under pub. Got it. Okay. So they were refactored in its own individual JavaScript file. Appreciate it. So within this quotes file, you'll find an AJAX call to one delete and to also post. And so let's take a look at the post one. It's going to say for all forms that have this class create form. Let's take a look at the index one again. Let's delete. Let's clear some of this stuff out. Close all tabs to the right. Don't save. Delete that as well. There's going to be a form over here with a class create form. Just a reminder that the dot notation with jQuery looks for a class. If it's going to be a pound sign, it's going to be a unique ID. Just a quick reminder. So when we look in the index handlebars, we'll see that there's a form. What does this form have? This form has one input with the ID auth and the name author, and it's going to have a text area with the name quote. Remember, like we said last time, for this information to be kicked back to the back end, it needs to have a name key. ID is not going to work. Value is not going to work. It has to be named. That's how we're retrieving information from the server. So the server inside the request body that we see in the server.js, where is it again? Here we go. We're going to be retrieving from the request object. Within the body, we're going to look for an author, and we're going to look for a quote, which directly correlates with the name that you see over here inside of the form. So when this button submit is executed, this JavaScript which has been pulled out into a separate file is going to say on the submit event, we're going to create our payload that's going to be kicked over to the backend, and then make an AJAX call to that endpoint, which is going to be of type post. This will be our payload, this data over here, and then once this is done successfully, I'll console log out, create a new quote, and reload the page. Location.reload. Questions here? Is everyone following along and beginning to see how these pieces tie together? Repeat it one more time? I will. Where did I lose you? Because there's a lot of different points over here. Is it the linkage between the server and the database? Is it the linkage between the JavaScript and the templates? Or is it the JavaScript and the server itself? The whole thing. Okay. I want to understand what's really the hardest part about the flow. maybe I could even draw it out a little bit. Because the better I understand where I'm losing most of you, the better I can explain this. So there's really, this is kind of like the life cycle for this app. You're going to have this JavaScript that initiates a call. That call can be Ajax, or it can just be, but it's going to typically be a submit action. That's going to hit our node server. Our node server is now going to communicate with our database. It's going to execute queries like select, insert, update, and delete. Database is going to return information back to our node service, and that is going to communicate with our template and render that information. So our template is going to take, we call it database information, in the response. And this section over here is going to be the request. This is going to display that information that we receive as a response from our Node.js server. And then our template is going to interact with our JavaScript when there's an action on the page, like an on-click event. So you can think of this as a click event, and JS would also help reload the page. And this is going to actually, let me get this. Slightly incorrect. This response will respond to the Ajax call. So this is going to be a response, database information. Questions on this workflow? You had a question?
No, it's a process.
Okay. So once again, our template is only communicating with our JavaScript. Our JavaScript is going to handle the on-click events. Our JavaScript is going to ensure that the page gets reloaded, and is just going to render all the information that our node server has provided. So, actually, and one more thing. When the page reloads, there's going to be a GET request. And you can think of this as the initial call for like page loads and sending back that info through the handlebars templates. This would just be a GET request. And you can think of this as a page load. Okay. One more time. When the page refreshes, we get that GET call. That GET call, our template is gonna load and it's gonna trigger a GET request due to the URL. That's gonna hit our server. Our server is gonna make a select call to our database. Our database is gonna get all the posts that we need. It's gonna return that information to our server. Our server will then render our page, so that will be this page load data, which loads our template. Our template, which is now loaded and has all the buttons and all the events all registered and everything, will now interact with our template. We'll call this, I don't know, this is us. We're going to interact with our template and create like a click event. Let's say we want to insert new data. That on-click event is going to trigger for the insert click. Our JavaScript is going to handle figuring out which endpoint we're going to hit to insert new data. For the posts, we happen to know that's going to be /API/posts. In our backend, we've already configured that information, that endpoint to make an insert to our database. So it's going to be a request through Ajax on an on-submit action, hits our Node.js, triggers an insert statement to our database, That's going to return a successful request to our server, and our server is going to provide a response to JavaScript saying, yes, I've inserted your post correctly, and then that's going to reload the page for us to interact and start this process all over again.
So the template is going to be our file that
that's the
handlebars?
Correct.
Yes.
All the
JavaScript would be the AJAX call from quotes.js.
Yep.
The node will be our server.
Yes.
.js, and the database, that's our
MySQL database.
Oops. All right.
Yeah. In a very simplified form, this is kind of how it all works. There's a lot of moving pieces, but you need to be aware that there's a very static flow. It's not going to do anything crazy unless you have coded something crazy. We know that for our template to load, we require a call to our database. So, on a GET request, hits our server. Our server's only job is to communicate with our database. You see, this is an isolated flow right here. Our JavaScript does not communicate with our database. Our template does not communicate with our database, just a node server. Same thing with our, well, actually, that's the only isolation, which is important because you don't want your front end communicating directly with your database. So you can think of Node.js as the middleman between front end and your database, and that's this only action. So every update and delete will require an interaction with the template, or how else are you going to be notified that your user wants to do something. You're going to interact with your template. That's going to trigger some JavaScript that makes a call to 104 endpoints that handle database manipulation, and then it's going to require a response, and then it's going to reload the page with that pertinent information. All right. Any more questions on that? Let's talk real quick about put and delete, and then we talk more about ORMs, because ORMs do help make your job a little easier when you're interacting with the database. You don't always have to remember all of the individual select statements that you need to create or the insert statements you need to create. But like I said, we'll get into that in just a second. I want to make sure you guys understand the solve solution, so when you're looking at it at home, it doesn't look so foreign. Just a reminder, the main handlebars layout just acts as a parent template for your index and your single quote handlebars.
Is there, most other stuff I've done, the script links are usually put at the bottom. Is there any preference?
I mean, I think typically if you have a large script file, they usually want you to load it at the end so that your whole page can load and then it begins to load all of your bulky JavaScript. That's usually the convention. But for our test purposes in class, it just doesn't matter. You'll notice that it makes that the first script, its source URL is to /assets JavaScript and then the quotes JS file. This is just an easy way to ensure that your quotes.js is accessible in your index and is accessible in your single quote handlebars file. So you wouldn't have to individually have a script tag in here just to get access to the different functions that you want to use. Some special syntax, though, is how does your front end know where your assets folder is? And how does it know it's inside the public folder? This is all tied together with this little statement right here, express.static. It acts as an easy definition to understand is this tells your front end where to look for front end assets such as images, CSS, and JavaScript. It's saying all of these items are going to exist in a folder called public. That's why when you look in this public folder, you're going to find an assets folder, which there doesn't need to technically be an assets folder. It could be anything, it could be called anything else. But it's going to give you the ability to have these references to your files on your front end. So it's going to say inside the assets folder, inside the JS folder, I'm going to find quotes, Same thing with CSS. Is gonna pull in the CSS style file over here, so on and so forth. That's all static does. It's just telling your front end that this is where you can find these different assets. Questions on that? Okay. So then we can also see that we can get an individual quote by going to /ID, and let's test that out. If I go to /2, you can see that it's going to now use that second handlebars template over here, single quote. And what does this do? All this does is that it takes the object that's passed back and saves the ID into the form data key, and then also puts the author and the quote just so we can display it on the page using handlebars syntax. And that's why we're able to see our author in this input tag, inside the text area, the actual quote, and then we have an additional button that has that data key ID, which would be over here. It's saved to a data ID key, and it has the class name update form, because that's what's inside our quotes.js. If we go to our quotes.js, we'll see that for any form that has the class update form, it wants to trigger an onSubmit event. We've seen this before, and with that onSubmit event, it's going to take in the data for those fields, author and quote, is going to get those values from that form, and then it's going to make a put request to API quotes. That's directly tied to this class name, update form. It's going to get these individual values and make a request to our server.js, which will be that node portion. When you take a look at the back end, it's going to have an app.put, because we know it's a put request for the specific endpoint that also takes in an ID, because we need to look for the quote that we want to update. Creates an update statement for the table's quote, and it sets the author to whatever is passed in, which would be request body author. It's going to update the quote to the request body quote, and this is the clause that helps you update that specific quote. We're going to say update quotes where the ID is equal to blah blah blah. That's going to be the ID that we're currently looking at right now, the ID of 2. If there's an error, it's going to create an error, else it's just going to return a successful 200. Next, we have a delete statement that is almost exactly the same as our update statement. The endpoint is going to be exactly the same as update, whereas API quote /ID, because when you're deleting a quote, what do you need to find that quote? We need an ID. It doesn't always have to be an ID. We could have added a where clause that says where the author is, I don't know, Shakespeare, and then you would have had to have a database table on the back end where author IDs are unique. So there's only one reference to Shakespeare, or your query is going to fail. It's going to be duplicate entries, and it's not going to know which one to delete. That's why we're using this ID, because we know it's always going to be unique. Why is it always going to be unique? Because it's auto-generated. You don't have to worry about ID duplication or ID mismatches, because every time it inserts a brand new object, it's going to add a unique ID to it. That's what simplifies things a lot. So when we get that delete request, it's going to delete quotes from the table and return a successful call. Now let's find that AJAX call within our JavaScript. What's up? Yes, so that ID is passed back to the front end, and then it populates the object. So when we're deleting an object, in this scenario, we're going to look for a form or something with a class, delete quote. On an onClick event, we're going to get the data from the data key ID. This is pretty much just saying we're looking for something that looks like this. Data-ID. That's what this data function does, as you guys will remember from previous exercises. So let's find that form or button. Here we go. So this button over here for each individual quote, let's load the page. Each quote is going to have a delete button. Each delete button is going to have a data ID. This is only so we can trigger the delete action for that quote. Once we trigger an on-click event on this button, for all buttons that have a delete quote, is going to use this generic JavaScript over here to, one, get the ID of the button that was clicked, and then secondly, send that ID back to our server through API quotes, type delete, and then that's going to delete the object from the database and then return back to us as successful. This object has been deleted, and reload the page, and so on and so forth. And this just goes through the same cycle for update and deletes over and over again, because this JavaScript is being triggered on all buttons that have this class name delete quote. This is just so that you guys don't have to have a whole bunch of duplication of your JavaScript. If the logic is the same for each individual button, then you can apply this on-click listener to all buttons with that class name, because you know that it's always going to receive the unique ID from this data attribute over here. And we're saving that data attribute to the front end when we call that initial GET request when the page loads for the very first time. It's going to grab every single quote from the database, post them on the page, and assign that unique ID to a unique button on the screen. So, questions on this exercise? Make sure you're understanding how that communication is being tied from the front end with the buttons, the on-click events, which trigger the database actions, which then cause a response, and that response then provides an update to the template. Okay. So, now we're going to talk a little bit about ORMs. We're going to look at exercise 12. Okay, let's see. What do we have in exercise 12? So in Node, there's a pretty popular ORM called Sequelize, which you guys may or may not have heard of. The whole point of an object relational mapper is to simplify the SQL queries that you're triggering on your database. We're not DBAs. Sometimes creating a complex SQL statement can be one, difficult, or two, we just don't have the time to remember all these nuances that happen with the language of SQL. ORMs were created to alleviate that. You could think of an ORM as the bootstrap for JavaScript. Helper functions that help make database manipulation a lot easier to deal with from a developer's perspective. We're not going to get into a lot of the complications that can sometimes arise with ORMs. So the example I'm going to show you is a manually built ORM. It's just so that you guys can understand the benefits of these type of things. So yes, inside of exercise 12, you're going to see inside the folder called config connections.js. Connections.js does just the simple steps that we've seen before in creating a connection to my MySQL database, and then also establishing that connection. That's all it does. And on the front end, all we do is require, in the ORM.js, we're requiring that connection.js to a connection variable. And that connection variable is what we reuse over and over later on. Now, let me update our database with this schema so that we have it. Blah, 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 blah. We're going to be playing around with a database called pets, And inside that database called pets, we're going to have two tables. One is a buyer's table and one is a pets table. Buyers have a auto-incremented ID and a buyer name. And then for pets, there's an auto-incremented ID along with the pet breed, name, price, and the buyer ID. The buyer ID is going to be a foreign key relationship to the buyer. It's going to directly relate to the buyers that we have in our database. So if we take a look, we can see within the buyers that there's two buyers, Kevon and Jane. I wish I could make this bigger so it doesn't look so small, but I can't. And then pets, we're going to see that there's a couple. There's a wolf, there's a bear, there's a hawk, there's a gorilla, and there's a tiger. And then it's going to have their names, it's going to have their prices, and it's going to have a list of the buyers who bought them. So buyer ID 1, when we looked at it before, was Kevon. We can see that Kevon bought a wolf, and that's that relationship it has between the buyers and the pets tables. Now, where the ORM comes into place is that we've created some helper functions that do some work that we might do over and over again within our JavaScript. So the very first function is select where. What it does in the back end is it creates a query string based on some inputs that you're providing it. It's going to say select from. Typically, between the from and the where, you're going to have a table statement. You want to say select this information from a specific table. That's what's being passed in. So we can see that from the table input, we're going to select from this table input where the column to search, which will be this placement inside this string query, and then the value that we want to search for. And that would be in this argument right here. And then what that's going to do is going to make a connection to our database and console log out the result. Where this becomes helpful is that we can now use this SQL statement over and over again within our server. So where we have, let me comment this out. We have this statement that says orm.select where. From the pets table, we're looking for the column animal name, and we're looking for the animal Rachel. Let's see what this prints out for us. Is it called server.js? What's it called? Yep. It's gonna show us. Let me move this down so you guys can see. We did a select where on the pets table. We're looking for the animal name Rachel, and the result is this animal Rachel over here, which just happens to be a bear, and it costs $745. And the buyer ID is 1, which you saw earlier was Kevon. We can then use the same function on the same pets table. We're going to look for the animal name. I don't know. Let's look for Marco. Animal name Marco. Run this again. And you can see now we've got Marco the gorilla. And ORM helps simplify the SQL statements that you're creating. I didn't now have to create a brand new MySQL.query function that did select equals from this table pets animal name equals Marco, because this is just a helper function. I'm going to use this function over and over again because the action that it's doing is the same. The only thing that changes is the parameters. This is a very simple example. As you can imagine, if you have a very complicated SQL query, it kind of makes your code a lot readable, because that same complexity that you build into the query can be reused based on the parameters that you're using. So if I have another table with the exact same parameters as animal name and price, but it just happens to be in a table called the zoo, I can reuse this query over and over again, because the only table input I'm changing, the only argument I'm changing is a table input. Everything else stays the same. You guys understanding some of the benefits sometimes with ORMs? 1, it reduces code duplication, and 2, it allows you to put reusable code in a single location, so that if you have a, I don't know, 5-page long project, you only have to go to one location to update some logic to say maybe maybe I don't know. You don't want it to return everything. You only want it to return the animal name. That's it. Everywhere else in your code base is only going to return the animal name. And is it animal name? Let me confirm. So when I run this server again, you're going to see that it's only returning the animal name Rachel, and I no longer get all this additional information that I don't care about. That's some of the power behind an ORM. So once again, let's use some of these other functions. Select and order. In this statement, we're going to say, give me a certain column from a certain table and order it by a specific column. So an example of this could be, let's see, select and order. We're going to say, give me the animal names of all the pets and order them by price. That's what that statement is saying. And it's going to send it back to me in descending order. So select animal names from the table pets and order them by price. Let's see what we get. Was that a question? Okay. No. Let's run this. You can see that now we have all these animals ordered in a specific order. And with Tobias at the very top, and as you can see, Tobias is the most expensive animal in this column. And the very last animal is Casey, which happens to be only 195, which is the cheapest. So some of the power behind an ORM. So what I would like you guys to do is to take 5 minutes to build this database on your own and to walk through some examples using these helper functions. So you begin to get into the practice of being able to use an ORM, so to speak. And I'll walk around and make sure that nobody's too lost. So once again, create this database using the SQL statements and then play around with the functions. We'll do this for like the next 5 to 6 minutes. It's pre-built. You're just going to reuse all of the information inside of exercise 12. And think of an ORM as just like a helper function for the database.
So we're just creating the database to run the program.
Correct.
Right, that's what I'm asking. Like SQLize. Okay, so we're gonna have to make a. We have to.
You gotta try to do everything.
Yeah.
I mean, that's not quite what he asked us Or is old guys trying to recreate the program in 5 minutes? Yeah, she's gonna become a ninja to
I guess because you don't use those functions anyways. So you have to. Yeah, well, no, that's the point.
So you don't have to write these
I'm just trying to.
only to change
What these does, what are the, that's why, what are these pros that you come But these codes, I believe you do have to write.
Oh, really?
Because like this seems very good. You know, you can make it more.
Yeah, these codes
Okay,
you
that
have
makes
to
sense.
write.
But
It's a lot
still.
because you have if you are trying to do this like
Well, that's true.
Yeah,
this
exactly.
thing is basically like one function, right? So if we want to do this like multiple times, we will have to like write this code multiple times. But with the OR, so we can just
It's not hard to the last shit. So it's funny that
so I guess it only helps, to my understanding, if you have to like repeat the same code, where you grab like data from the database, if you repeat the same thing like multiple times, then it would be helpful. But if you only do it like once, then it doesn't make sense.
allowing you to know so you can use how in front and then you add so face up, base, and then you just do all out. Inside the stage, to take all the styles. Pretty much, I think that's like the easy version. Oh yeah, why do it? That's the same reason. So write them all out, like replacing the question marks with oh, okay, that's what you're talking about.
Yeah.
So did you try to run it?
So handlebars actually converts into these certain things. So you can think of the handlebars template as an each rate that is a special
So we will pass the function.
that is, yeah. Yeah, that's right. So handlebars converts its handlebar models into that basic so that's why when you look at your actual page,
Right now?
You want to change everything that's on the team,
Yes.
so yeah. And then you just,
I just typed.
let's run your server and then actually you'll see that it's an entire
so you're just copying everything and then just changing all the data.
But it's not. It's
yes. The seeds to populate
So we use that with that's no, that's not it's not gonna use the same thing.
Oh.
That's how
Yeah.
I mean, appreciate it. Oh yeah, no problem.
I guess this is a simple example.
All right.
Yeah, but then how we're gonna check?
Which one has the most? Okay, so I just want to take a quick break from this solar exercise to walk through find who has the most, because that really is the most complex in there. So when you take a look at find who has the most function, you may or may not be seeing details of this query that you recognize or do not recognize. Whenever you're in doubt, it's always best to go with a very simple example and see what happens. So I'm going to comment out these others and focus solely on find who has the most. So we want to find which buyer has the most pets. By eyeballing our data right here, we can see the buyer with the ID 2 has 3 pets versus the other one who has 2 pets. When we take a look at that buyer, we can see that buyer is Jane. That's what that SQL statement is trying to do. It's trying to grab information from the database and figure out which buyer has the most pets. Now let's see how it's trying to do that. It says select, and it's going to pass in the very first parameter, which happens to be a table column. When we take a look at our example, we're going to see that that column is a buyer name. So it's going to give us the buyer's name as a result. When I run this statement, you're going to see that all it's returning is a buyer named Jane and the count of the animals that she's purchased. That's all we're expecting back. So with that information, you begin to reverse engineer the SQL statement that you see over here. You see that the only results you're going to get back is a buyer's name and a count of the pets that she has. That's what these statements are saying. Select column 1, table 1 column, and then this count is going to be of the second column, buyer's name and pet number. So let's add a comment over here and write this SQL out ourselves. So select buyer underscore name, count, what do we see on that page? Buyer ID, as count from table pets. Is that what it is? Nope, table buyers is the very first one. From left join pets on. You see, it just gets more complex. You get 1, 2, 3, 4, and then table 2 is the next one, which is pets dot table 2 foreign key, which happens to be, I think it's buyer ID. Buyer ID. And then equals buyers dot same one, buyer ID, group by table 1, which is buyers, order by count descending limit to 1 result. Very, very, very long statement. But it's important that you write out this entire example and run it in your SQL inside your MySQL workbench yourself. Because our expectation is that when we take this raw SQL statement and we run it in MySQL workbench, then we get the exact same result that we saw when we ran our server, which is buyer name Jane, count 3. That's all it's doing. So when I go to my query, I try and execute, copied the wrong one. Let's start over here. I try and execute this, assuming I haven't messed up the parameters. There we go. Unknown column, buyers and buyer ID. What's it actually called inside? The buyers called just the ID. All right, let's fix that up. All right, run this again. Unknown column, buyers in the group. Okay, so when we did group by, did I mess it up? Group by the very last one, which is the table 1 column, which should be ID. All right. Column ID statement is ambiguous. Wonderful. All right. You know what's going to be easier than this? Let me console log out the query string. It'll be so much easier. All right, let's run this again. There we go. Nope, that's not it. Let's see. Inside this query string, blah, 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 blah. Okay, let's actually, let's see what MySQL gives us the ability to see what that actual query statement is. Let's go to node MySQL. Let's see if we can get it to give us the raw SQL, because that would probably help you guys with debugging in the future. All right, let's see. Terminating connection. Is it a query in the result? Raw SQL statement and node MySQL. Let's try this one. Well, I'll find it. Go back here. So, by column 1, column, just the ID. Okay, let's remove these statements and make it simple. So aggregated column without a group by, left join, blah, 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 blah. Let's make this even more simple. Buyer in the field list. Oh, isn't that buyer ID? Let's see. Well, as you can see, SQL gets quite complicated sometimes. But when you're able to finally build out a SQL statement that makes sense and does what you want it to do, by just passing in these different parameters, you can get to use the read over and over in different scenarios. So while I figure out how to get a raw SQL statement from this specific query, take some more time to make sure you guys understand what's going on with this ORM. Helper functions, explain it amongst yourselves. I'll probably get one of you guys to come up here and explain in your own words what you think is happening. So take 5 more minutes to take a look at that.
Essentially all the JavaScript.
There we go. The results, blah, blah, blah.
like that.
Which one?
It's like the long period.
Oh yeah, it was actually incorrect. I'm trying to fix it.
I know I can use like it anyway.
Yeah, sure. Yeah? Want to slack it to me? Cool. Yeah, sure. That works. There we go. Perfect.
Oh yeah.
There we go. Thank you very much. Aha, forgot the backticks. That'll do it. These little backticks right here. Buyer name, blah, 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 and group by buyer name. Okay. And while we do that, click on this. Okay. Let me pull you guys' attention back one more time, because this is a pretty critical piece. You might have noticed that there's 2 question marks and a single question mark sometimes. What that does is that the double question marks are typically for table names and column names, and it will replace those arguments with backticks. So inside this, the correct SQL statement that you kindly gave me earlier, you'll notice that there are backticks over here. These surround column names and table names. It's just SQL statement syntax. And then the ID itself, you'll find that sometimes values like, let's see, values like in this where clause over here only have a single question mark, and that will just inject the value that you pass back in without backticks. Diving into when to use what can sometimes be complicated. Just remember that typically double question marks denote either a table usage or column usage, and when you see a single one, it's typically for a value that you're using in like a where clause. So if I was to replace this SQL statement, which is much more simpler, it would be select animal name from our table, which would be pets, backtick pets, where I don't know, column to search ID, backticks ID equals 1. That's how that kind of gets interpolated on the front, on the back end in SQL, in raw SQL. So if we search that over here, run selection, you'll see that it gives me back the animal name. Very important to denote in case you were curious why there were double question marks versus singular ones. This is the raw SQL that it outputs. Yeah, sure, I can select that out. Whoops, let me not do that. Okay, there we go. Okay. 2 more minutes talking amongst yourselves for RMs, and I'll randomly pick someone to explain it in your own words, because sometimes that can be more useful hearing it from a student than just me.
Yeah.
Third one. You have to get rid of the single quotes.
Well, I have one without single.
So the function name is find who has the most.
I think that's
That's easier to understand than select count as count as.
I didn't.
So ORMs provide you the English readable friendly function and hide all of the single less.
No, because you don't have a single quote.
Yes.
Oh, okay.
When you're trying to run that, you
You
gotta
could.
get rid of that.
But they're already basic.
For example, delete, and then-
Yes.
All of them?
All these supervised
No, no,
things
no,
come
just
down.
that one.
But keep in mind that you need to tell.
Those quotes we don't. Because I
In
don't
the
have
middle?
that. No, no, yes, everywhere. Do we need them? I don't have them. You see? My line doesn't have them.
Yeah, ORMs are specific language for data. Yeah, I mean, you can think of this as just, it could have been, it's just a
Nah, I
list
don't
of
have an
functions.
answer. You should ask the network.
It could be a helper function that makes a call to my graph. It just happens to be. The reason we teach you this in this fashion is because it helps you get over the hump of
Probably it's not necessary.
understanding what the functions
I
are.
guess that's.
This is what they're doing. They're encapsulating helper functions that you would use in your graph organization. Yeah, yeah. I did.
What's that?
So these are the parameters. You're gonna see just options defined in JavaScript in your first discussion through here. Oh,
I thought that question mark refers to that. I guess
they're
they're the same thing.
In JavaScript, it's gonna be
That
sources.
question mark is replaced with that.
And assets.
All
These are the files.
That's a wild like Jesus. Yeah. It's a long project coming up. It's like a sandwich or something. Like, God. You stop at an Italian restaurant.
Made it fresh.
Okay, so.
Put it straight
What is
in
it? The
here.
other Parmesan cheese?
What is the benefit of doing it this way instead of just writing the whole thing? And I feel like it's more confusing. Having all these question marks and heading
It's readable.
Alrighty.
Cool.
Okay, I'll explain it as I understand.
Could I get everybody's attention real quick? We'll get a brief explanation on ORMs.
All right, so the ORM is functioning as a helper function to our database. Should I use this or that? Doesn't matter.
Feel free to use my computer.
Okay. All right, so
This would be all the example files.
okay, so as he mentioned, have to first create a connection, JavaScript, export that out, call that in the ORM JavaScript file up there, and then create a variable to store the functions, and then create these helper functions, select where, all those three functions, and then within those functions create these strings in there, and then use the SQL language, select, and as you mentioned, the double question marks would indicate the table or column, and then the single ones for value. And then let's see, you need to call the connection again with the connection.query, reference those strings that you put in the function earlier, and then certainly put an error and a result. If there's an error, you throw an error. If not, console log the result. And yeah, you just do the same thing for different functions. And once that's done, you just export that ORM onto the final file, which is the server.js. And yeah, you just require that. And yeah.
So when would be a good situation to use the ORM?
If you have multiple database files that you wanna call, or if you have multiple databases that you wanna call specific values within them. If you want to be more specific in the changes you want to make.
Okay, and so typically, just to reiterate before, it's all about repetition. If you're doing the same SQL statement over and over again, you don't have to write it out with its own unique syntax over and over again. You could pass in these individual arguments into helper functions, which will build that raw SQL statement for you, and you only need to worry about SQL complexity once. You can just reuse that function, which has an English-friendly function name to help you understand what exactly is going on. So for that complex SQL that we saw on the back end, where it had select blah-de-blah count from left join, once you've figured out that complex SQL stuff once, you no longer need to figure it out again for each individual instance. You can just give it a user-friendly function name like find who has the most, and it'll do exactly what you think it's supposed to do. And if I'm like a brand new developer, you can think of an ORM as a black box. I don't need to understand the SQL complexity that you create on the back end. I just need to know that if I use this function name, find who has the most, is going to give me the result of what I expect to find, which would be find the buyer who has the most pets. Question.
You said there's libraries for this, right?
Correct.
Okay. So helper functions.
Thank you very much. Cool.
So those are helper functions, and you pass arguments into it.
Mhm.
You do whatever you want.
Correct.
Okay, I just want to make sure. I
Yeah.
understand.
I'm not going to get into how these more popular ORMs understand your database, because there's a very specific way to do that, but we're too early in the game for all that.
But okay, so you do have to know.
Yeah, you need to tell your ORM, this is what my database looks like. Now, provide me a way to do some certain type of logic.
Okay.
Yeah. So let's be really, really general with it. Let's say an ORM has a helper function that gives you the very first item in the table. It doesn't matter what table it is. It doesn't matter what database it is. You could just say, you can give your ORM some information saying, for this database school and this table student, give me the very first element.
So the
That-
best way to
Mhm.
go about this is look at the ORM and then create your table, or
No, so the whole point of an ORM is that it's a black box, and you just need to give it the information that it needs, which is 1, a database connection information, 2, some data table information, and then the data column information. So let's use that school example for a minute. I know that to select the very first element from a table, this is the SQL statement. Select everything from any table, first result. It could be a zoo table. It could be a classroom table. It could be a park table. It doesn't matter. This SQL does not change. The only thing that changes is the table that I'm interacting with. And it's going to use the exact same SQL statement over and over again in different scenarios.
limit it to 5, and
If you wanted to limit it to 5, then you could pass that value as a parameter.
But if you use a library on ORM, it's already made.
Yes, they're gonna give you that flexibility.
Okay, so that's
Because
what
there's no point in a publicly used ORM is going to be restrictive. It wouldn't be popular. It's going to be so flexible that anybody could use it for any type of situation.
Because if you use something like Bootstrap, like the flexibility is not that great. You have to use
Sure, granted. Which is why Bootstrap is good in some scenarios and not so great in others. Yeah, that's how. So if you're building an open source tool, I mean, flexibility is key. You need more people that are able to use it for more scenarios. That's how you build popularity. So yeah, does anyone have any more questions on an ORM, the scenarios you would use one, why it's useful? Question?
Just like I know this is a problem. What does module.export do?
What does what?
Line 42 ORM.j.
Line 42. Oh, this one right here?
Yes.
That exports that variable so that it's usable when you require it. So for example, we're saving all of these helper functions in a dictionary to a variable called ORM. I'm saying that when I require this file, ORM is going to be the object that I receive from my require statement. So inside of the server.js, you'll see it's requiring /config/ORM.js, and it's assigning it to a variable called ORM. That's because that ORM variable is what got exported out of that file. Have you guys seen that syntax before?
It wasn't about restaurants, but we didn't really go over it.
Okay.
My tutor explained it basically just to keep everything separate, and if anything breaks, you kind of know where it's coming from,
Yeah.
rather than looking at like 5,000 lines of code.
Yeah. So raise your hands if you want me to explain that one more time. The whole importance of an export. Okay. Cool. So just to reiterate again, the whole point of an export is to, how can I say? So in this file, there's only one var called ORM. And actually, no, there's two. There's a connection and there's an ORM. And I could also create a var x equals 1 on a var, I don't know, y equals 2. I'm doing some logic in this file and it's only being contained to this file. Let's say I want to finally provide a means to export specific logic out of this file. The only way I'm going to do that is by using module.exports. If I change it from ORM to X, when I require it inside of the server, you'll remember that X is equal to 1. And that's the only way I'm able to give an outside file access to the variables inside of this specific JavaScript file. So inside of server, I would do require orm.js, and the only thing I'm exporting right now is X, which happens to be 1. So when I console log out orm the var, what am I expecting to see? Correct. I'm only expecting to see 1. So let me run the server, clear it. You're only going to see 1 that gets printed out because that's the only variable I'm exporting. You see how we kind of like, we've contained a lot of logic inside of this file, but the only thing that we're making public to other files is the var x. That making sense? All right. And you can export a whole number of things. I could export X, Y, and ORM if I so felt the need. But it just so happens in this situation, all I'm exporting is one variable. Cool. So let's move on. Let's take a look at exercise party database. You'll notice a party database is going to be a carbon copy of the ORM example when it comes to the ORM file itself. The only thing we're giving you in the unsolved is going to be the schema and the seeds. And then the README is going to tell you what it needs out of that information. You're going to create an ORM just like this. You're going to create a var, name it whatever you want. It's going to have helper functions that create SQL statements. And then you're going to export that variable so that it can be reused in your server.js. So let me slack out the instructions. And before we Let's see how much time we're going to spend on this one. Okay, let's take a 15-minute break, and then when we get back, we'll do this for another 20, 25 minutes. 15. I'll be right back. Cool. Pets, clients. Oh, that's good. Parties TV. Okay.
I didn't send you all that. Yeah, they're ready. Yeah, they're ready. They have their CSS. And they're linking it inside the main template. That main template is we use index and single. Because you see these classes labeled and all that stuff.
Yeah. Well, yeah. Why know that?
Yeah.
Oh, so it's not nothing.
Well, not necessarily, because you still need to make a reference to it. And that's what's happening over here. So when you add this reference to style CSS and process.js, you can now use all the CSS styles inside of children's templates because they're all going to be injected. So you can pretend that index.handlebars is being injected there, single quotes.handlebars is being injected there.
Oh yeah, no.
Those exist in this way. Oh, you run a business? Okay, so let me tell you what that link is. That link is created right express.static. This is saying take all files and folders of the public folder and give them access to them. So everything inside this public folder, assets, CSS, assets, JavaScript. That's why you can do this. Say, you can say slash asset slash CSS and use that file. That static function is what I'm sure. Oh. Yeah, very good.
They left that out. That really screwed me up. And you assume that it's just a piece of cake.
Yeah.
That's not cool.
Because
then you think you screwed up.
Yeah,
And
you can add a lot of confusion.
right. So I don't know if that was meant to be gone over. We have existing static.
Some weight?
Yeah, weight and I'll do a static motivation.
Okay.
That's
I mean, it's only left, she's gonna be like, I thought I had it all the same, it wasn't working.
yeah, that's a very critical one. You can name it whatever you want. There's no special like conventional answer. Sure.
Control C and to bring out Jace Wood station. still break time.
He's good with it in the class today. Let's do exercise instead of games. What is she trying to do right now? Game.
Not trying to play game.
Looks like you're playing games.
Trying to be more efficient. Be more safe.
Okay, so before we kick off into that other exercise, I just want to go over one more time about this very, very critical line right here in exercise 11, which is express.static. What this is supposed to do is it allows you to say, I have all of these assets that I need my front end to load, such as CSS, JavaScript, images. And it's saying you can find those resources in a folder called public. And that's how your Express server is going to be able to serve this information to your front end. So when I load my page, you can see that it's loading my CSS. I have a reference to my CSS, which is /assets/css/styles.css. But you could also imagine that there's a public over here in the beginning because right now they exist in the public folder. When you go to Sources tab in your debugger, you'll see you have access to the Assets folder itself. Inside the Assets folder, it has everything you expect it to have, which is your CSS folder and files, along with your JavaScript folder and files. Now, if I commented this out, and I ran my server, refresh my page, you'll see that we're going to get a couple errors right here in my console. Those errors are going to say 404 cannot find quotes, 404 cannot find style.css, because it's going to try and access them from this URL endpoint right here. You realize that in this particular server.js, you have not defined URL endpoints for the GET request assets/css/style.css. You haven't defined that. When I take a look at my server.js, the only endpoints I've defined is // /ID /API quotes /API quotes with an ID. Not these ones that are related to my assets. That is the power of app.use express.static public. It's going to automatically define these endpoints for you. So you don't have to respond with your actual CSS on the back end. So when I hit save, it's going to create a get request endpoint for this style.css. It's going to create assets endpoint for my quotes.js. So when I start my server again, and I refresh the page, it's able to make a get request on those endpoints. You'll notice that in the networks tab, you can see it making a get request to these URLs. You'll notice it's making a get request to localhost 8080 /assets /css /style.css. Those are being automatically created for you with that static helper function. So just wanted to reinforce that so that when you have an Express server and you're wondering why it's not accessing your CSS files and your JavaScript files, you've most likely probably forgotten to establish those endpoints by using that helper function. So there's a little bit of confusion behind that, but I just want to reinforce that. Any questions? Cool. So before we run out of time, I want you guys to start on exercise party database. You're going to define an ORM very similar to the exercise 12 ORM. Not this one. Let's look at the README. I want to go over on what is expected by this ORM. Your ORM is gonna need to accomplish 4 different scenarios. 1, we're gonna start with the easy one so that you guys can have time to work on the harder ones. Console log all the party names. And the second scenario is console log all the client names. They sound pretty similar. That's going to give you an indicator that the SQL statement is going to be very, very similar. The only thing that seems to change in this statement is the name of the table that I'm referencing. One would be for the table party, one for the table client. So if I was to write this out in a raw SQL statement, I could say console log all the party names. I'm going to assume select, I don't know, I can't remember the name of the column name, so I'm just going to guess party name from the table party. And I can assume that is going to be exactly the same for my client, except we're just going to change a few more things. We're just going to change the table that we're referencing, client, and the column we're referencing, client name. This is a perfect candidate for an ORM because what did we technically pass into our function, so to speak? You can feel free just to yell it out. We passed in the column, and then what else? And a table. So that was going to be your first hand for this exercise. Very, very similar to the examples you saw in exercise 12. So let's do this for the next 20 minutes. So at 8:40, and then we'll look through the solution. Just a reminder, this is exercise 13.
select table, column, select column, table, HTML. What they're doing is they're doing a client selecting an ID, right? And this is a primary ID, and then dumping in the ID becomes the client. See? And then these columns, and it's asking you to put those columns. More it's asking you anything with the group graph. Like a party type, it pulls out every one of these. I think in a second, it's plugged in with the tables. And this thing here. See, this ID.
Oh, yeah. You have to, you get the, right, because it's table, yeah.
Okay.
You got the job. Because you don't want to.
For each of them. Oh, you gotta change it.
Right.
Yeah.
The table, well, what is the table is the.
Oh, yeah.
I know, it's something about you.
Everything.
Yeah.
I did that. The idea is if this is this is we're asking you to do this.
Yeah, so where ID equals.
These things are doing that. See, there's a drawing. So I think what it's doing is bring back the name and client name. And the thing is, remember, it's a left join. Do you know why? Because the name of the client is in one table, and the name and the party with the client is involved in. So that's why you have to join. If you go down, everyone knows it's here. Right? So if I had the table, I had an ID of 6. And then I was 6. That's why I have to join this table.
Not this. But if right now
It's connecting to
Oh, you know what? I left them out.
So everyone loves random.
No, not really. If it helps you understand how to structure your
So you have,
solution, that's perfect.
by that, okay, that's one.
Yeah. And then let's make sure that.
But if you really look at this,
Understanding the solution.
who's the next guy? There's no way of knowing, so that's why we have to use the left two. They combine the two.
Is that a reserve? Okay, yeah, no problem.
Those are syntax.
Talking, also being able to explain your problem is one of the concept that we directly teach, but you get practice by
I know, maybe,
all
maybe
this
because you have this
and
connection.
understanding how to ask the question, which ties into your understanding how to search on Google to get the solutions to that. And plus Google in that search engine, you get a lot of filling. You need to figure out how to convince your Google search to give you exactly what you're looking for. That's the same that you practice.
Right, but I understand.
Correct. Yes. Well, that's good. Yeah. Mm-hmm.
Not fire.
Okay.
I appreciate it.
Yeah, no problem.
Pretty much the same. Both of them.
Well, I don't know. I leave it from up.
You can name it whatever. They match the question marks.
Now this one comes back alphabetical.
What's that? The first two?
You see the difference?
No, the first two.
They can do the same.
Everything, it lists all the by little.
I know, I did it again because I didn't know they were similar, but yeah, they're pretty much the same.
Because you're just really, it's just selecting a column from the table.
What I think helps me out is if you guys start going from backwards.
The fourth.
Oh, the client sometimes.
Well, these are the difference.
And then you join one. So right now you have select star from table parties.
So each one has their own.
So in the parties table, there's a client ID
Well,
column.
there's no,
So you can join the two tables on
So you just client that ID equals.
yeah, party equals, well, yeah. So the, yeah, you select and then whatever columns you want from each table. And then inner join, or yeah, so select the column names from the first table.
Do it here.
Inner join the second table, or left or right, I guess it doesn't really matter in this case. Inner join second table, and then on, and then that's where you say clients ID equals parties
Do any one of these. So ORL, we don't have to do npm install ORL.
Yeah, it's confusing.
Where the hell do we get it then?
SQL is
Yeah.
confusing. I did
Syntax for that is it's frustrating.
Here's my
Where does
graphic
it get
now.
ORL?
I did SQL a lot, like 5 or 6 years ago, but I've forgotten my
You created the variable.
Yeah, but
And
we don't
there's
have
functions.
to npm install ORL.
Well, no, there's so
And I mean, it's
That's why he was there. So when he was asking me that, I wasn't sure why it was not. Now,
you don't hear correct.
And let's actually
so the only npm install we have to do on this one is slide line as well. Alright, that's cool.
I think I guess walk you through the steps
Already changed it.
how can cement. copy and paste file.
This is just referring to that. You made that. You don't build it. There isn't anything. But in order to use it, you have to do it.
Now let's execute all of that. And now you can see creating the parties database and the client's tables and parties tables. Now when we look on the schema side, this goes our actual schema that we created. Parties database. Because now here we hit refresh. There we go. Now you'll see those two tables inside that drop down. Now let's get rid of all this and just throw it on dummy data.
So they give you some clarity, so you can type. And then we go to
Get the
where you go do that. Where you
Get inside clients.
where you type equals
And what we're doing today is just
whatever.
kind of creating SQL queries.
And this is how you build
This place and give you
a secure database. You connect ID to connect an ID to name and email. But you wouldn't include all the data that's with it. So when you log in to a website, you put your name and your password. And then once that's correct, it gives you all the information you need. So when you get right. So you're just an ID out there instead of having your name exposed. So that these two hash.
yes. You can think of them as arguments or yeah.
And you put that password in and you sign up. So when you sign up, you're done. And the password is dumped to that thing. So essentially, you just get a little bit of a push. And when you,
Yeah. So now copy and paste this
I
statement.
guess,
We're gonna see
when
it
you log in,
in my SQL
it's a
page.
get.
And sometimes
So
the
you
best
get the
way to run
password,
separate things
and then it
is to
compares it
run that SQL
to if it's the same, unless you
without
adjust
just
it.
a very string. Not even a, that's all it is, just a string. That string is just
Yeah.
assigned. It makes sense to me. Else.
yeah,
We're gonna mimic.
And it says it's a get, and a get, and it's the same, then move on to the next page. But we haven't done anything like that.
Okay. And now let's get rid of this oops, security rather than development. And we're gonna
How do you
replace
build that?
question marks, passing message, functions. So let's take a look at that.
There's a sign in for the front thing? Oh, the one with, yeah, that's what I'm thinking. That's one of the features of it.
Cool. And that's exactly what's going to do. It's going to give you all the party names inside the database.
And then give them happy
So
answer.
when you actually execute that function in your code, this is exactly the results you're going to get. Yep. And you're just going to walk through the same flow for everything. Yeah, no problem.
So what we're doing essentially with the use for like login passwords, essentially that we have two different separate tables and you just match up the ID.
Yes, exactly. So, I mean, if you could think in a very like
Simple.
simple way, that's what you're doing. You have a table to confirm the password being passed in is equal to what it has to. Yep.
Well, could you tell us about hashes? Like how would we convert whatever password
Yeah.
to a hash? Is
Let's
that
talk about hashes already.
no,
Oh, okay.
he said we were doing You want to do like a logging page.
Yeah,
Like what you prefer method would be hashes because a lot of companies just the last thing you think about security.
Yeah, so security. So
Yeah.
the hashes would not keep your password as clear text. So if your password is 123, it would grab that 123 and generate some sort of random string that you could later decrypt to be
So would it be that random string be in the database itself?
Yes.
Until
That's what you actually see.
Okay.
So if I'm an attacker and I get access to your database, I'm gonna look at all the passwords. I'm gonna see a jumbled string. It's not gonna actually be your password.
And essentially, simple level, this is what we
Yes.
because we would like to incorporate some kind of logging system.
Okay.
And
Yeah, and you would just store it in plain text or whatever.
when you log in, would it be a get request and then you put the parents?
It would be you would register it as a get request. Actually no, it would be a post.
Okay.
Because you would be posting this body of the password.
So you're logging in as a post.
Yeah, so it'd be like a form submit.
Oh.
Your form submitted, it would register to a post in the backend. That post would take the information which would be the user and password and do a select statement saying, look for a user with this ID or this name, where the password is equal to blah blah blah. Yes. Cool. That makes sense?
Thank you. That makes sense too. You actually have improved it. Half the battle is speaking of linguistic notes. Like Google Food is really powerful if you know the right words. Yeah. A lot of times you just don't know the right words to say at the beginning of search engine.
Oh, okay. What version of MySQL do you install?
Yeah, I got the first two.
Because I know there's a lot of issues with
Well, there was roles and parties. Yeah, that's what I'm looking at.
Let's just type in MySQL space / dashboard. Wow. Yeah, let me send you URL.
Need another one? Oh, sure.
I ran into issues as well. He was walking through steps, show you the steps, uninstall everything, install 5.7.
So basically that is if we write down it's right for ourselves and then step.
I think so. That's what I did for the first one and it worked fine.
Let me circle back.
Okay, so let's take a look at the solution real quick. So for this example, we're expecting you to use the data that we provide you inside of the SQL, the schema SQL, which creates clients and parties in a parties database. We also have some dummy data providing you information in those individual tables. But the core of this is to pretty much create an orm.js. And in your orm.js, you're going to have three separate functions. One is a basic select, where we're saying select from a specific column from a specific table. So it's going to give me everything inside of this table, but just that column that I'm looking for. So if I look at my server.js, I'm going to have orm.select party name from tables parties. And it's going to give me all of the party names that exist in parties. So let me run this server. Blah, blah, blah. Party database, npm install. While that's going, node server.js. Whoops, what is going on? Cannot find module, blah, blah, blah. Where am I? npm install. Node server.js. Okay. So we'll see that it returns to us all the parties that exist inside the parties database. That's pretty straightforward. Our second RM select would be return to me all of the client names. You'll notice that this goes this goes hand in hand with this hint that I gave you in the very beginning of class. All we're doing is a select statement defining the column of information that we care about from that database. Is just going to give us everything that's in there. So when I do select client name and clients, in the back end is going to use this function, select client name from clients, and print out all of this information that you see over here. Question?
I've gotten used to seeing, can you go back to the other also on line 6, I've gotten used to seeing where stuff like what to select and table input are variables that we create, but that's inherent to the ORM, right? Like what to select is a specific
No.
thing that we're looking for.
So that can be named anything you want. This could be named A and B and A, and this could be B and B. As long as you understand that they pertain to the column that you want and the tables that you need, doesn't matter. And I just want to reinforce that even though this is an ORM, this is an ORM that you created. That means all of these functions can be named whatever you think makes sense. All of the SQL query statements can be built in the way that you want it to be built. So don't get too caught up in the fact that things are defined a certain way in this solution. This is written in a way that hopefully makes sense to you, but if the language used does not make sense to you, feel free to change it. If it breaks, figure out why it breaks. That's the best way to learn. Then for select where, it would be another similar statement to the previous statement where it says we're going to select everything from a table where the column passed in equals a specific value. So when I use server.js, I'm saying select where parties, select from the table parties where the party type column equals grown up. And you'll see that that would be, well actually, there's two references. One party ID with an ID 4 and the party name is whiskey, and then another one with an ID 5 where the party name is cigar. But the key thing over here is that the party type is the same in each of these items. So it's only going to return me back the results where the party type is equal to grown up. And that's what we passed in over here, and that's what's referenced over here in the select where statement. This where clause is what helps filter out all the excessive noise. Now, left join. I slacked out a resource because sometimes joins can even be tough to explain. And the best way I always remember how to use a join is by using a diagram. The example over here is saying select from column names. That means the only data I want back my result are going to be the specific column name I provide over here from a specific table with a left join on table 2. Left join ties, the syntax in SQL ties directly to this last statement over here. It's going to say, give me all of the information that I require from table 1 where there's a similarity with table 2. That similarity is defined over here. So if in table 1, this column name is equal to a table 2's column name, then give me where they intersect.
and that might be out of like 10 entries. If there's only 2 entries where the column name matches in table 1 and table 2, that's going to be the result that I get. So that's what happens in a left join. A left join would be giving me the information on this table on the left side. Same thing happens with a right join. If I use a right join instead with table 1, it would be flipped and would give me all that information that I care about from table 2, at least in those results. So when you look at that example and you try and
it would have to be already somehow linked with a foreign key, right? So
yes,
okay.
that's how they're tying those 2 tables together. So in this example over here, they're saying select. Actually, what are we passing in? Let me grab that. RM left join. We're saying select a client name from table. Who is this? Actually, this is passed in blah 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 as a single entity. Yeah, let's call it. Let's print this out. What to select? Console.log. What to select? And I am going to comment everything else out to reduce the noise. Because you'll see that they're passing an array in as the very first parameter. So you want to make sense of that. So when I clear this and run this again, you'll see that this column that gets passed in, this first one would be an array of client name and party name. Let's inject that in here. And then it would be from the clients table that we're getting information from. So let's write this out. Select backtick these items from clients as T1, and then we would add these items to the query string where this gets replaced with parties. And then on where T1 is equal to ID and client ID. All right, let's throw that into our MySQL workbench and see if I got all the arguments correct. All right, so unknown column. There is no such column, but there's a special way syntax in which this is handling it. So let's maybe try just these separated. Oops, let me remove this. Okay, there we go. So with some debugging, because the MySQL library that we're using does a little bit of syntax massaging to get this to work. What we notice is that even though we passed in an array as what to select, it took this array of client name and party name and is almost like a shortcut to say, instead of individually passing these in as 2 separate arguments, I'm just going to pass them in as an array, as an array of arguments, but it's going to break them up on the back end to be separate items that we want to get from the result. So it's going to say select the client name and the party name, as you can see from these columns being printed back out, from the clients table, and left join that with the parties table, where
client ID is equal to the party client ID. Even reading that is a little confusing. So make sure that when you are trying to understand these type of left joins, that you take your time and try to understand what we're trying to achieve. We're trying to achieve this very last statement over here, where in the clients table there's an ID that matches the client ID column in the parties table. Now let's go look at the content. Inside the party table, we can see that they have client IDs of 1, 1, 2, 2, and 3. That's our foreign key relationship. So we can assume that in the client table, there has to be a client ID of 1, 2, and 3, which you can see there is. If that isn't true, then this whole query will fall apart. So those are like some golden rules that you can at least understand when you're trying to break down query statements like this. So this is our golden truth. We want back a client name and a party name. We know this exists in two tables, in our clients table and our parties table. And the relationship between those two is going to be the client ID, where in the client table, it doesn't need to be referred to as a client ID because it's just an ID table that is an ID column that happens to be in the clients table. But then inside of our parties table, we're actually explicitly defining this as, for this specific party, it relates to a client ID. I don't like the way they've written this as, and so we're going to name this actually something else. We're going to call this client table. Name this client table and call this party table. Whoops. Write it again. Haven't broken anything. Now this is a little bit easier to understand. We're going to say from table clients as a client table. You can think of as creating a reusable variable in my SQL statements. So I'm going to take the details from the clients table as this variable client table and left join it with the parties table as the party table variable, where in the clients table .id is equal to the party table .client ID. And let me slack this out so that you guys have that breakdown, because it can be a little confusing. Well, very confusing.
What are we expecting the result to be for that one in English?
The result that we want back is the client names and the party names where those two tables intersect. And so we can tell that there's a party name called Everybody Loves Raymond that has a client called Bilal, and so on and so forth. But let's add some more information now here. Right now in the parties table, we can see that they only have client IDs that match the clients. But if we add a brand new client, and let's give them, I don't know, let's call this for Bob, we now have a brand new client over here that has no parties. So when I run this query, again, it's still going to give us Bob, but there's going to be a null value when it comes to the party name because there are no parties that exist for Bob. That's a very important differentiator with this, because this left join is only going to give me details, at least party name details, where they intersect, where the client name is equal to the party, the client ID is equal to the party table client ID. Else, it's just going to print out all the client names for Bob and print out nothing for the party name. So walk through scenarios like that when you guys get back home of adding more parties. So if I add more parties over here, let's give this an ID 6. I don't know, golf, party type grown up, cost $10, but no foreign key. I'm forced to add a foreign key relationship because That's how we define the schema. The schema said every single data point inside this table has to be related to a client that exists. So when I edit this row, I'm going to add a client ID. Actually, let's change this to 4. So 4 to our brand new user. Go back to my query, execute it again, and you see that Bob now has a party name of golf because that relation has been created. So very, very important that you guys go home and play around with these query statements, play around with the data, and kind of like see how this changes the results that you see in front of you. So, questions?
Do you know of any literature that regards organizing tables, like SQL databases, so that you can join things easier?
So what you're saying is pretty much a how to build good databases and good table relationships.
I would imagine that as these things start to expand, they probably become pretty complicated.
Yes, yes.
To gather information from.
That is very true. I'll try and find some literature that people have said has worked for them. Yeah, I'll look up something. I can't remember off the top of my head, but I'll find you something. So next, we got 30 minutes left. We want to talk a little bit about asynchronous functions. So if we look at exercise 14, now is that exercise 14? Let's see. Okay. Nah, I don't want to look at that one just yet. Let's look at exercise 15. Inside exercise 15, we're going to see some examples, very simple examples where we have a function called sum that takes in 2 arguments, num1, num2, and returns the added result. Same with multiply, is going to multiply num1, num2, and then we have a function called add callback, and that's going to return the results of function 1 plus function 2. I would like you guys to run these individual exercises locally for the next 5 minutes, and we're going to talk about what we expect to see when each of these exercises are run through. Feel free to ignore one on click for now. We'll talk about it in a second. So execute 2 through 7, and we'll talk about what we're supposed to see for the next 5 minutes. Remember, this is, well, I guess heads up, this isn't a trick exercise. I just want you guys to guess what you're expected to see on the screen and then confirm that you see it. And a lot of these exercises don't have console logs, so console log out the result and make sure that confirms what you expect. And feel free to partner up if you see certain scenarios that you're not expecting. All right, cool. Catch you later.
Yeah.
So it's not.
No, because that's going to be so you're going to just pass those arguments and then SQL's statement X because it's what you just created in that order of objects. Also, you should say dot you're assigning to this key select value. Oh, that's it. Yep, that's another key. Nope, this is just raw JavaScript. The ORM itself, no, that's just that could be Emmanuel's special project. We're using the same name ORM just to reinforce that what you're building out is personal experience. But this isn't any type of special syntax. We're just creating a project that holds special yeah. This is just things we send assigning JavaScript to a variable which happens to have keys that relate to functions. It just it doesn't have to be like this, it's just a way you can have everything all in one file. Okay. Cool.
All right, let's go through this as a class real quick. So for exercise 2, I'm going to console log out the result of add callbacks. Is this exercise 2? Yep. Let's do node to JS. What's it going to return back to me? It's going to return back to me 21, which is just the basic arithmetic that's going on in here. It's going to sum up 2 and 6 and where are we passing him? Nope, it's going to multiply 6 and 2, which is going to be 12, and it's going to also sum up 6 and 3, which happens to be 9. 12 plus 9, 21. Very basic. No surprises there. For number 3, we're going to console log out that result as well. When we do that, it's 22. No surprises there too. I believe the math is supposed to be correct. This is the same for 4. This is the same for 5. It's the same for 6. Well, actually, it's not the same for 6 because something funny goes on over here. When we get to exercise 6, I don't know if you guys got to this point just yet, but when you node number 6, you get undefined. Does anyone have an idea why it's undefined? Why in exercise 5 I was able to get the result that I'm looking for. Exercise 3 I was able to get the correct result of the addition of the individual callbacks. What's missing in number 6? The return statement. And so we're making a call to anything goes. Anything goes is a function. And that function is going to execute other functions. But if you don't return any values, just executing anything goes is going to return nothing. Not brand new information. So what I really want to do is add a return over here. And then when I rerun this exercise, we'll see the answer that I'm looking for, which is 17. Now, this ties right back into the async problem that we have over here in exercise 14 that we'll go through. In server.js, we're requiring our ORM, as we've seen multiple times before. We have a function called selectWhere, and then that selectWhere is going to pass in 3 arguments: parties, party type, and grownup. If we look at the ORM, what we expect to see is we're going to have a select everything from table parties where the column party type equals grownup. That connection query is going to execute, is going to pass in the arguments, and then it's going to return to us the results. So when I console log out that data, I'm expecting the results to be what we were looking for, and we're going to console log it out. So let's try that. So let me go to that exercise, node server, and you can see that it's undefined. It's undefined even though we're returning the result. Anyone want to take a stab at why that's still the case? What are we missing? Correct. So where would you add a return statement? Yeah, where would that return statement go? How would I get the result that I want into data? Anyone want to take a stab? If you go back to orm.js, we're returning a result, but that doesn't seem to be what we're getting back when we execute this statement. Select where. So if we were to make any edits to this, what might a logical option be?
Add a callback to as the last parameter in this function.
As the last parameter to this function.
And then instead of returning the result, you could do callback result, and then do it in the server.js. You would include you would make a callback function that returns whatever the.
So yeah, so that's definitely a good solution. But before we get to that good solution, if I was still trying to debug this, I might do something like so. I might add a return right here and say, return me the results of this function connection.query. So when I hit save, I know I'm definitely getting an object back because I've directly returned this function execution. So let's try that out. So when I hit return, what do we see now? What we see now is not exactly what we're expecting, which is information from our database. What we're returning is, scroll to the top, the query function. The query hasn't, it's the object that's created before, or the object that's being created when we call connection.query, but not necessarily the return of our results. So that's where we might implement this additional callback that you mentioned. So if we now look at the solved solution, we're passing in an additional function parameter called CB, our new callback. This callback is now being reused inside of our connection query and is taking in a result. Now, that result of this function, if we look at the server, is going to be this function right here. We're passing in an anonymous function as a fourth parameter, and we're saying take whatever result is passed into you, assign it to data, and console log it out. This is a way of stringing functions together. So once again, because it's a little tough to understand, let's call this the full name, the callback. We're passing in a function as a fourth parameter, and we're executing this fourth function within the callback execution scope of the connection query. If you remember in the unsolved solution, that inside the result query scope, we're returning a result because at this point, the select query has gone to the database, it's returned a result that has populated in this result object, and we're trying to return it at this particular point. So we have access to it. So we're saying, give me this result, pass it into another function that I have passed into you, and do the logic of whatever this function is telling you, which just happens to be console log this data. So when I try to run that solution, oops, let me npm install where, yeah, 1 second. You'll see that we get the results from the database that we're looking for. Question?
I understand what's going on, but
Yeah.
let's say if I want to do it differently,
Okay.
can I store the values that I get back, let's say in an array, pass those values to my server, and then use those values as a parameter to return?
Say that one more time.
So the ORM is passing callback.
Yes.
On the select, right?
Mm-hmm.
Oh, but then you're getting the data of the parties and all that. You're getting it on the ORM or you're getting it on the server?
So you're getting that information from the ORM file.
Okay, so can you store it there somewhere else and then
Oh.
pass those values to the server, not in a callback?
No, you need a callback because all of this is operating asynchronously. So you could think of this, I'm going to get into a little bit of the weeds here, but there's multiple threads happening in this particular execution flow. One thread is going to start up here, grab the ORM, execute this function, and then end. Another thread begins when this ORM now makes a new connection query to the database. It's going to come in here with that initial first thread's execution and spin off a second thread on line 7. And then it's going to end immediately. A new thread, that second thread goes out. It might take 10 seconds. It might take 15 seconds. It's going to work to get this information for you in the database. Is then when that's finally done, it's going to return and provide me the results. I'm now going to take that second thread's results and execute a third thread, which is now my callback function. That is now going to execute this function over here, and it's only going to be within the third thread scope that I have access to the results. So whatever extra work you want to do is going to have to be over here. Extra work. Because thread 1 has ended, thread 2 has ended, thread 3 is now the one that has my results from the database. So you can't do anything else over here. This is a no-go. Nothing with the data happens here. Because all of that work is happening in separate threads. No, that's just how JavaScript works. Yeah, at least Node specifically. It's an asynchronous language. Questions? Because that can be a little confusing to understand the different threads and execution states that happen within JavaScript.
So I know, like, in some scenarios you can, like, set a function to be asynchronous and then...
You can also force it to be blocking.
Yeah. Or
Yeah.
Like an await statement.
Yes.
Is there, like, a golden rule as to when to use callbacks and when to use await?
It's really up to what you're up to you and what you're trying to do. you might have a valid reason for waiting for certain logic to do whatever it needs to do and return a result before you continue that initial thread's execution workflow. I'm trying to think of a good example on when that might be the case. Yeah. Okay, cool. When a user makes a request to a database to a website, the request and response time between the request coming in and doing some work and then getting a response, if done in a non-asynchronous way, can take a very long time. So let's say during that workflow, I'm getting information from a third party about movies. My user can make a request to my web service, and forgive me because this example is not going to be the greatest of examples, but when I make a request to my server, I can get it to block and wait for the entire time it takes for me to get that movie data, then take that data and add it to the response and return that response to my user. And let's say that takes 20 seconds. Or I could asynchronously tell my user to, when it makes a request to my web service, initiate that second thread, but immediately return a response to my user saying, your job is being worked on. Find your results at this link. And when I go to that link, there's a little countdown on how long it's going to take for that work to finally propagate. It helps with a user experience flow. It might be better for that user, so they're not sitting there wondering, have you ever been to a website where it's just loading for like 45 seconds and you don't know what the hell's going on? So it can load in like 2 seconds and tell you, be patient, we're working on getting you the next page.
Right.
And now I can just see my countdown.
When it like takes you to a redirect and it's like your download should begin.
Exactly. Things like that. So it depends on what you're trying to do with your website. Questions? We're getting a little bit into the weeds here, but it's important information to know. Okay. We have 10 more minutes. I'd like you to play around with exercise 14 and come up with questions as I walk around to try and reinforce the idea of asynchronous JavaScript.
Well, yeah, anytime.
Is there anything I can help reinforce? Do you understand the threads example I gave? Yeah. How one thread ends and another one begins? Yeah. That's pretty much the core basic JavaScript. There's going to be a life, a time to live for every single thread, and new threads are being executed on function execution. And the only way to understand at what point can you use certain variables is by understanding the scope in which a thread is working. So when you saw, let me pull it back up.
When you saw this execution over here, the time to live for this thread is going to be the time it takes to hit that database and return a response. And then that's it. By the time it hits this line over here, line 10, thread 2 is dead. Thread 3 now begins its life when this callback is executed. And that's now going to go back to that server.js and execute this scope of work. When this scope of work is done, thread 3 dies on line 7. So knowing that, you know that within the scope of this function, you have all the time in the world to play around with the data and do whatever it is you want. But the moment you leave that scope, access to the data is gone. So I can't play around with the data at line 10 because thread 1 that was king of that scope is already dead. Yes, you're going to be operating within this lifeline. That doesn't make sense. Okay. Yeah. So when you're playing around with it, add console logs to the data over here. Add console logs here. Add some more, I don't know, logic, just so that you can reinforce when things break and when things occur that you're not expecting, because that'll help you understand the life expectancy of these different threads. All right, let me walk them out.
Yeah, sure. Every single time that you plug your in and install in this SQL, if it wasn't for this class, I'd say yeah, sure, because it's your longer there and you know certain libraries will but because each exercise is its own contained ecosystem, it doesn't make sense for you to install something. Because you might be using one version of Express and one exercise, and another version of Express and you know, I was just wondering if I could, I guess let's say if there was no updates or anything, would your machine be able to filter out between all those different tools? So it will just kind of make sure to whatever you use. So you could almost think as the local module supersedes the global. So even if you had a globally installed Express version 5, if you locally install Express version 7, you use that within the scope of that. That's pretty cool. And if it doesn't exist, then of course it's just cool. Cool, thank you.
Sorry, I didn't hear. It's function inside the function.
Where's the verb? All your common laws are done. So it's not gonna,
I just have no idea. That's more of
let's try that.
You could just submit it.
You're not actually console logging the function itself, you're only console logging the return method, which is the line of that's all you That a little bit. Yes. That's how There should be no turns to the right. So I don't think they can I'm at the gym, I'll cool down today. I don't fucking understand. But you don't want to split. So you don't want to get the gym let's say it's still never communicated.
Like, well, could you give me a list?
Yeah, I can go next
Something to work with, right?
They got me working this weekend. No problem, man. And I'll be back on Saturday.
Look over the,
You on Saturday?
yeah.
I ain't fucking.